Okay, so I wanted to go over the solutions to the net ionic equation problems. In the first couple problems, you'll notice they actually give you a little bit more uh, information than in the later problems. In the later problems, you actually have to determine what the products are and balance the reaction. Um, so in the first one, notice that they give you both the reactants and the products, and they also tell you whether things are solid or aqueous. All right. So even though they give the information for aqueous versus solid, you should be able to determine whether those things would have been aqueous or not. All right. For example, sodium chloride, it says aqueous. All right. Even though we should know that sodium chloride is soluble in water, we can look over here and we see, okay, all group 1A salts are soluble. All right, sodium is a group 1A salt. Also, it says all chlorides are soluble except for these exceptions. So we would think that this would be aqueous. All right. The solubility guide says that all nitrates are soluble. That's why this is aqueous. Lead chloride. All right. Why would we say that that is a solid? Notice that all chlorides are soluble except for, and it mentions lead as one of those exceptions. So that's why this would be assumed to be a solid, all right, meaning it's not soluble. And again, all nitrates are soluble. That's why sodium nitrate has got the aqueous suffix here. So I went ahead and balanced that here. We had to put 2's in both of these locations. And remember, when an ionic compound is dissolved in water, it exists as the separated ions. All right, so instead of writing it as 2 NaCl aqueous, I can write it as 2 Na plus aqueous plus 2 Cl minus aqueous. Here, this compound right here could be shown as its separate ions. Notice there's only one of the lead ion, but there's 2 of the nitrate ions which are dissolved. This one right here, I don't show it as separate ions because it's a solid, meaning these guys would be bonded to each other when it's in that solid form. All right, but these guys, since they're dissolved, show them as the separate ions. All right, so looking at both sides of the equation, we notice that there are 2 dissolved sodium ions on both sides of the equation, so those do not participate in the reaction. Also, there are 2 nitrate ions. I can cross those out, and let's just bring down what doesn't change. All right, we have a lead ion, which is dissolved, plus 2 chloride ions, which are dissolved to make solid lead chloride. Right, and it's important to note on this that the spectator ions would be sodium and nitrate. All right, so next problem. I've gone ahead and just put a 2 here to indicate that's what the balanced reaction would be. And again, splitting this up, this would make 2 sodium ions plus 1 carbonate ion. The iron chloride, since it's aqueous, would be 1 iron plus 2. Remember, we get this charge of the plus 2 because we know that each of the chloride ions is negative 1. And so if we have 2 of them, there's a total of negative 2 charge here. So this iron has got to have a positive 2 charge to balance that charge. All right. So that's how I know that charge right there. We have our 2 chlorides. All right, again, the solid material you draw as the ionic compound, and then the 2 sodium chlorides you show as the 2 separate dissolved ions. Your sodiums are the same on both sides. Your chlorides are the same on both sides, so those would not be shown in the overall reaction. All right. In fact, they're called the spectator ions. And the overall net ionic equation would be everything that's left. All right. Notice that when I draw this, you could have put either the iron or the carbonate first. All right. But generally, when we're drawing ionic compounds, we tend to put the positive thing first, and then the anion, the negative thing, second. And that's why I reversed the order when I redrew them. All right. But if you had drawn these here in different in the opposite order, that would have been fine. Okay, again, draw everything showing anything that's got an aqueous, draw it with its as the separate ions. The potassiums are the same on both sides. The chlorides are the same on both sides, and just bring down everything that stays the same. This would be the net ionic equation, and in this particular case, the spectator ions, even though I haven't written it down, would be your potassium ions and your chloride ions. All right. This next one right here is a little harder because it doesn't give you the products. All right. So how do I figure out what the products are? First of all, remember, it's a double displacement reaction. You're gonna give the compound from the cation from this guy with the anion from this guy. That would be ammonium and nitrate. Let's see what the formula is. Let's crisscross those. That would give us 1 ammonium and 1 nitrate. All right, we don't have the parentheses in here because there's a 1-to-1 ratio. All right, phosphate and zinc +2. Again, remember that zinc makes a +2 ion. That would give this formula right here. And so when we look at that total equation right here, we need to add some coefficients so that they would be balanced. So it goes 2, 3, 6, 1. All right. So in terms of solubility, all right, one of these is going to be dissolved and one of them is going to be solid. All right. Remember, both ammonium and nitrate are very soluble ions. So this would be your aqueous compound. And if you look here, how do we know that this thing right here is solid? If we look here, where does it say? Okay, all phosphates tend to be insoluble except group 1A. All right, and notice that this is a phosphate and this is not, zinc is not a group 1A ion, so that would be assumed to be insoluble, which is why we put the solid right there. Okay, so bringing down everything where you break up any ionic compound into its component ions. All right, and I had to kind of write it on 2 lines here because it's a lot to write. I see the 6 ammoniums on this side. I see the 6 ammoniums over here. They cancel out. The 6 nitrates here cancel out with the 6 nitrates right here. Bring down everything that you don't cancel out. This gives you the overall net ionic equation. And in this case, the spectator ions would be ammonium and nitrate. All right. So for this next one, here is the balanced reaction. Again, you're just swapping the cation and anion between the 2 ionic compounds. Write out the dissolved compounds into their constituent ions, and write out any solid material as the compounds formula. Your nitrates will cancel out, your sodiums would cancel out. Bringing it down, the things that don't cancel out, your magnesium gets brought down, your carbonate gets brought down, and those are going to combine to make solid magnesium carbonate. All right, so if you mix these 2 things together, the only chemical reaction that occurs is between the magnesium and the carbonate. Everything else was dissolved in the beginning and it stays dissolved in the end, and therefore it's not really doing a chemical reaction and would be considered a spectator ion. All right, think of them as they are just dissolved in water, watching the reaction that's going on around them. All right, this reaction right here, we're going to get sodium bromide and barium sulfate. How do we know that this is a solid? Let's see if we can figure that out. It said all sulfates tend to be soluble, but it mentions barium as an exception. So barium sulfate would not be considered soluble. So that's why we can put an S there for solid, or actually an S right here. And breaking things apart into their ions, and then looking at what's the same on both sides. Our bariums cancel out, our sodiums cancel out. The barium gets brought down, the sulfate is still there. It gets brought down, and then we have barium sulfate right here. This is your overall reaction, and these are your spectator ions. Okay. Last problem. We got silver nitrate with magnesium iodide. All right. That's going to overall make this balanced reaction. So how do we know which one of these is solid and which one is aqueous? All right, remember, anything with a nitrate is going to be soluble, so that's why that is aqueous. And what about silver iodide? It says all iodides are soluble except silver, lead, and mercury. Right, so that's an exception where you'd say that it should be not soluble. So silver iodide is soluble. All right, so is solid. So breaking things apart into their ions, your nitrates would cancel out, your magnesiums would cancel out, and bringing everything down that doesn't change would give us the following reaction. All right. The reason I'm not going to call this the finished net ionic equation is because if you look at the coefficients, we have 2 of these combining with 2 of these to make 2 of these. And one thing hopefully you'll remember about balanced reactions is if there's a simpler ratio of the coefficients, then you should express it like that. So that could be simplified to Ag, aqueous, plus, and by the way, there should be a plus right there. Iodide, ion, aqueous will yield silver iodide, AgI, which is a solid. All right, and in this case, the spectator ions would be the magnesium and the nitrate.